Hi, I'm Jason Lee. I'm professor of computer science now at the University of Hawaii, formerly University of Illinois Chicago at EVL. I'd also like to introduce Luke Winabo from EVL. Someday he'll be in Hawaii too.
Maxine heard it.
Yeah, the flight's been booked. Okay, we're going to show you some hopefully fun stuff. I won't talk too much. We'll try and just show you more stuff if possible. But first of all, I just want to give some of you who may not be familiar with Sage a little bit of background, starting with what it is. Sage essentially is software, like an operating system for driving really big tile display walls, allowing you to treat it like a giant canvas, and where you can juxtapose, position, move around information. So you can make sense of what's going on in your data, hopefully more effectively. And previously, this technology was focused on supporting high-performance computing and visualization. But over the years, we found that the community of users and their applications have grown so much so that we've had to broaden our software and our application bases. And in fact, in tracking the past, 8 years or so, this has been the growth curve of Sage display walls. And these are walls that are all over the world of varying sizes, probably one of the largest being here at Cal IT2. And I think the second largest is at Texas Advanced Supercomputer Center. So you can see, so in the past year, there's been a huge uptick of this. So Sage has been around for about 10 years. It all started with the OptiPuter project that was part of Cal IT2 and EVL. And it's grown significantly since then, to the point that we felt that in order to address the new user community needs, we had to think about how we were going to move forward into the future, taking advantage of new technologies. So I'm leaving this slide here so that if you collect this as PowerPoints from your visit here, you'll have a list of all the other Sage sites around the world that have built these systems. And this project wouldn't have been possible without generous support from the National Science Foundation for over 10 years, as well as collaborations with Cal IT2, NTT, Monsanto, and even Argonne National Lab. So you're here to hear about Sage 2. This is all new software. We left practically nothing of old Sage behind. Wrote it completely from the ground up. I'm going to let you in on a little bit of a secret right now. So in high-performance graphics, we typically develop all our codes in C++ for the sake of performance. Well, we decided that in looking at the technology landscape, where things were going, we're going to take a little bit of a gamble. We did a little experiment, and we decided that we're going to try and implement all of Sage in JavaScript. And so everything you're about to see is running on browsers only. So this giant tile display wall, in fact, consists of how many browser windows?
16, I think.
16? Yeah, 16 browser windows. So everything from the way we control, here we go. So Luke is revealing all the browser windows.
So just,
yeah,
if you have done web development, that's a console of the browser. So just to prove the point, it's really Chrome browser. So for a long time, graphics on browsers really weren't powerful enough to do anything, especially to the satisfaction of people in computer graphics. Now that you have control over the GPU from browsers, the shaders and so forth, we can now do actually cool things and interesting things. So let's jump right into the Sage demo. What you're looking at is my PowerPoint slide, which in fact is being pushed to the screen using Sage. So actually, this is my actual desktop screen. If I were to pop this to the front, this is actually my Sage interface that I see on my laptop running from the Chrome browser. When you are trying to connect to Sage, in a moment you're going to all get to do this. Basically, all you need is a Chrome browser, no other software. And in fact, there's Luke. Luke just pushed his laptop onto
the Sage wall. I can click on any one of these things and move them around. I can even take this beautiful Sage logo and hide it so we can make more space for stuff to come. So the way we use Sage a lot in our research meetings is that students will come in and they will open up their laptops and they will push all their laptop screens onto the wall, just like this, so they can do their weekly updates. Luke is creme brulee, by the way. And so that's display pushing. And what we do here is basically we leverage Google's display pushing services, so that now, instead of just pushing the entire display screen, we can actually push individual application windows that you might have on your desktop. So let's say you have some material that is private and stuff that is public. You can now choose between what you want to show, like maybe what Luke's doing there. The second thing we want to show you is the whole new user interface. What we've learned in developing Sage, especially when we run it in very big display wall environments, is that the user interface becomes a huge burden if you lock it down to one particular position on the screen. Like if you had a menu bar, for example, you're going to be racing, marathons with your mouse across the screen to get stuff done. So now in Sage 2, you can launch a menu practically anywhere on the screen to control things. And a lot of this is because at EVL, we have a touch screen on our display wall. And what we'd like to do is sort of touch it and bring up the menu and start controlling things from wherever we are. And this is especially important when you have several people like me and Luke, both simultaneously, or whoever Greg is, doing stuff at the same time. So for example, Luke can bring up a little menu.
Okay.
So that's Luke's menu up there. Sort of designed radially for optimal selection with minimal movement. Luke can bring up this palette, bring up the media browser, and then throw some images onto the Sage wall. And just as with the old Sage, you can throw up images, you can throw up PDF documents, you can throw up videos, and play them all back.
I'm going to push you.
I'll give Luke a chance to catch up.
Which one? This one, for instance?
Maybe I'll give Luke a hand and move stuff around for him. I'll move this around here. So as you can see, we're playing a video directly off of the browser. It's fairly well synchronized. We're still working on the synchronization. Make it small, you can make it big. Again, these are browsers, right? Who would have thought we could do this with browsers? The browser makers, yeah. Oh, genius. So that's interesting because we heard about a month ago that Google was working on a large display project, whatever that is or means, and we're not quite sure. If anyone has any contacts with Google, we'd like to teach them a few things. All right, so let's move on. So this was the interface that I'm running off my laptop. In fact, if you point, and Luke, what Luke's going to do is he's going to take a tablet. So he's got an iPad, and you can do an Android too. We don't discriminate. And by pointing to this web address up there, don't do it yet, guys. Wait. By pointing at the web address, he can bring up the browser, and what he will get is the exact same view of what I'm getting with my display pushing.
Should I take a picture?
Yeah.
Okay.
So actually, you can see this is the view that Luke gets on his browser. And Luke, why don't you flip your screen around to the public just to show that we're not faking this.
Oops. Yeah, here we go.
So watch me. Watch this. I'm going to move this window. And if you look carefully at Luke's thing, can you see it moving? Yeah. So it's perfectly in sync. So any browser that happens to be open will see this in sync. So one of the fun features Luke is going to show is that from the browser, Luke can also open up the same media browser. But instead of taking the media from his iPad, he's going to take a picture of you all and post it into the Sage wall. So here we go. Smile, everybody. Say Sage. So what's kind of cool about this is imagine you're doing some kind of emergency response type application. You could be in the field with your iPhone, and you could be taking pictures, and you could be sending them back to home base, right, constantly. And in fact, as one of the tests of this, I was driving around Honolulu, like, here's a beach, here's another beach, here's another, and I was sending it to Chicago.
And it's warm and you're cold.
Why don't we send it to Hawaii?
Yeah, in fact, by clicking and dragging this up to that icon, Luke can actually send a copy of this picture to Hawaii.
Yeah, to Chicago.
Right? And so now that he's done that, I'm going to go to the Hawaii site. I think I'm here. So top right-hand screen is my screen. And in a moment, when it updates,
Wireless.
yeah, wireless is getting slow.
Everybody shut down.
Yeah, it's Greg now.
Yes.
Yeah.
I'm waiting.
So when you actually see it up there, it looks like this. This is Hawaii's tile display, and actually this is the picture that Luke just deposited in Hawaii. If someone were there to actually look at it at this moment in time. Okay. Oh, someone moved it. Someone is in Hawaii.
Oh, I sent it over there. Sorry.
Someone just moved it.
Yeah. I was trying to show the Hawaii interface.
Oh, okay.
Your students work 24 hours a day.
Yeah.
So.
Okay, I'm going to go back to.
So yeah, that's the Hawaii interface. So it's 4K screens over there.
Oh, I'm going to go back to screen sharing here. Okay. So what else can we show you? Let's see. This is my screen share for a moment. Let me bring it back. So as you can see, it's a completely sort of democratic screen. Anyone can create chaos if they want. They can jump in with their laptop, multiple pointers, right? Okay, so let's talk a little bit about this media browser business. So from the media browser window that Luke showed you earlier, and maybe Luke, you can bring it up again. One of the cool things about doing everything in JavaScript is that now we can begin to leverage this huge community of software developers who are, crazy about developing cool JavaScript applications. So for example, Luke can bring up like a really high-res Google Map viewer, right? So he's going to bring that up, which is right there. Notice it's really small, but he can blow it up, and probably much to Google's chagrin, this cluster is now pounding on Google's servers with like 30 requests for images to fill this high-resolution screen at native resolution.
Where's my cursor?
Can you show us Manhattan? Because we saw Manhattan 8K yesterday.
All right, Luke, you drive.
Yeah. I probably try to make it a bit smaller first. I'll use my cursor.
It's pretty cool to see almost the whole United States.
So yeah, it's displayed at pixel resolution right now, so it's a lot of data. Is that zooming? Ah, I zoomed too fast.
Iowa.
Yes.
Fly over state.
Let's see. Where did we get? Just make it a bit smaller.
So I guess if Google really needed a good test of its gigabit networks, this would be it, right?
Okay. Yeah. Yeah.
There you go.
Let's see. Is it? Yeah. Is it not zooming? Oh, here we go.
Here in Newark.
That's bad. Let's go to all the way to the street level.
Yes, that's definitely.
That's where we buried the body.
It's there.
Right. So just to show you that we can really take advantage of the GPU underneath, so Luke's going to bring up an app that's actually using the GPU shader. So Luke, let's bring up the car.
Something is off there.
Yeah, something's very strange.
Let me close this one.
So as you can see, this is a real-time rendered car, which Luke will spin around in a moment. The weird viewport discrepancy is not our fault. There's something going on with 3JS, which we're still trying to figure out. Oops, what's going on?
Oh.
It's Google fighting back.
Yeah.
Yeah. Let me restart it then.
Jason, what is the status of the software plan?
So as you know, this is beta. So yeah, we released it in beta actually 1 month ago, just less than 1 month ago. It's all the source is out there. It's open source. And
Yeah.
WebGL hit a snag. So we'll start that again.
What is the infrastructure behind?
So in a moment after we finish this, we're going to run through some slides to show you the infrastructure.
Oops.
Massive 404.
Is it reloading? Just a second.
So Luke, are you just restarting the web server, the Apache?
No, so it's not based on Apache, but the web. Yeah, I restarted the web server. I restarted both, in fact. The display and the server. I don't know why it's not displaying. Here we go. It should be fine. Yeah. So let me bring back the PowerPoint.
I'll do that, Luke.
Okay.
You go ahead and bring up the 3JS.
Mm-hmm.
Am I good?
Mm-hmm. No?
Hmm?
Oh, here we go.
Yeah, as you can see, that is an app that's running on 3JS, which is a high-level JavaScript 3D library based on WebGL. The the environmental mapping is all done in the GPU, not in software. So now we have the ability to write shaders and control them from within the web browser. And so one of the things that we've also done back in Hawaii actually is to put in a stereoscopic rendering shader. So now if you have a 3D wall, you can also look at some of this geometry in 3D. Again, all in real time. So, you know, the shader, the browser is really finally sort of grown up, right?
No plugin required.
No plugin required.
Wow, wow, wow.
There's something going on with the wall, yeah. All right, anyway. So moving along, I think this is the part where, I think, Luke, is it your turn? So we're going to dive in a little bit deeper. Actually, the one little feature we want to explain just a little bit, we showed it a moment ago, is this collaboration mode. So any document that you have on this wall, if you drag and drop it to one of these buttons above, green means they're connected right now, red means they're not, you can copy that document to them and it will appear on their wall. The other mode is this perfect mirroring mode. So if you have two display walls that are identically shaped geometrically, you can do a perfect mirror of everything and all the content on the wall, including the pointers, so that you can now point at each other's media. The one other thing we're working on, which we aren't showing today yet, is that if you had two asymmetric walls, it will figure out how to carve out a space that's canonical, that'll fit with both, and create that as a public space in which whenever you drag windows into it, that part is shared, everything around it is public. But that's still sort of under development right now. As I said, this version of Sage is running in cluster mode, and Luke is going to talk through his slides about the architecture, but he's also going to explain to you how you can actually get started with a Sage wall for as little as $6,500, believe it or not. Okay, take away, Luke.
Okay.
So Luke, I'll let you push your slides up to continue.
Okay.
So Luke again has shared his screen. He can move mine out of the way.
Up. Yeah, so I will talk about the architecture. So as we said briefly before, it's all based on JavaScript, and on both sides, on the client side and on the server side, it's JavaScript. So you might be used to use JavaScript on the display side or the client side. So you write a JavaScript and the application, you use Google Map API or all kind of APIs. But in fact, you can now use the JavaScript on the server side too, through something called Node.js, which is basically the JavaScript runtime from Chrome, basically, that has been extracted and wrapped up into a language. And so if you're used to use Perl or Python or something like that, Node.js is exactly the same thing. It's an interpreted loop of JavaScript, but this time you can run it on the server side. And it lets you write basically web servers, but much smarter web servers. So writing a web server in Node.js takes 5 lines of code, but then you can add everything you want around to do special behavior. And that's what we do in Sage 2. And on the display side, we leverage HTML5 and a whole range of APIs that you see these days popping up everywhere in JavaScript. So like WebRTC to do video conferencing inside the browser without plugins. So I think Microsoft, Skype, Lifesize, all the guys are looking at WebRTC to do video conferencing on the laptop or the mobile devices. And we show that we're using WebGL on the display side also, so you can run pretty advanced rendering techniques in all in shader base if you want, and a whole range, big range of cloud APIs that you can leverage online these days. So as we said, we use a web server and web browser for everything. And the main thing is a web browser gives us a runtime to run application. So we don't have to compile anything. We don't have to port application. As long as our code runs into Chrome or Firefox and IE for that matter, we can run it directly into a new machine, for instance. So as long as you can install Chrome on the system, we should be able to run Sage 2, either the display side or the client side, either way. So the core is a customized web server. And so we use a little bit of web server just to deliver a few pages, but most of it happens through secure WebSockets between the client, being the display, and the server. So we send messages between the application and the server to keep everybody synchronized, basically. And since we use Chrome, basically we get all the security for free. All the APIs are there to do communications through HTTPS and secure WebSockets. It's just you change a URL basically in your communications protocol, and you get secure communication for free. Something, for instance, that we never addressed in Sage because it's really hard to do security. Well, here we say, okay, Google guys can do security, and so we are going to, for instance, leverage that right away. And something you might not be aware is it's possible to do high-performance networking through a web server, through a Node.js web server, streaming data to various clients, basically browsers. And we've been able to push as a test, just as an experiment, to push 10 gigabit out of a server to feed data to, I think it was 6 display nodes. So we can feed multiple gigabit of data to each Chrome browser if we want to. So that was just a test to prove that, yeah, we're not going to get stuck with the networking, for instance. So we've seen with the graphics, we have WebGL, so we can get high-performance graphics. And with the networking, we think we can get also high-performance throughput. So I think we're pretty confident that we can push that model pretty far. So what's the architecture? Oops. It's not updating.
Hmm?
People stop playing.
Oh no, that's not me.
Yes.
Somebody back there.
No, it's okay.
It's okay.
I mean, it should have. It's of course it's worse when we do demo and we get. Maybe I'll leave it that way. Let's see. Maybe I'll try again.
So Luke, what
Yeah.
do you linking? Is it just Wi-Fi or?
Yeah. I'm just through Wi-Fi right now. Yeah.
From your laptop
Yeah.
to the street?
Yeah. Exactly.
Yeah.
Yeah. So everyone here have maybe like 2 devices in their pocket. So there's a lot of traffic in the room. Even Steve Jobs was getting mad when people were using wireless in their room. So we didn't see that behavior when we rehearsed, honestly. So we have a server in the center that basically maintains the state of the system. The server doesn't do much, but knows everything about everybody involved in one session. We have display client on the bottom. We have an audio client that. So we were playing audio earlier. The video was having an audio track, and you could hear the audio track. So we have an audio manager, and various interaction client and input client. So we have done work with touchscreen, for instance, and Kinect, and so on. Basically, leveraging what we've done with Sage over the years. But you have to understand that that view could run all in one machine if you want. It's just a conceptual diagram, but you can have all those components in one machine. It's completely possible, and we use it that way. So we released very recently a beta release in binary mode. So you can access that to the sagecommons.org website, and we have binaries for Windows 64, the latest Mac OS, and one version of Linux, because we didn't want to build binary for all the Linux versions. And if you are pretty familiar with source code and so on, so you can go to the Bitbucket website and download all the sources. So it's completely open source. But as a first step, we wanted to provide binary so people can just download the package, install it very quickly on their laptop, and get started. And the idea is really trying to get feedback early on the design. So what we really want is for you guys to start developing application and see if you can integrate your own APIs, your own data sources, and write application and give us feedback to see if that works or it doesn't work for you, and we can change it along the way. So the main site, sagecommons.org. And the source code is at bitbucket.org. So if you're familiar with GitHub, it's very similar to GitHub, basically. So if you search Bitbucket and Sage2, you will find it. And so we have an issue tracker where you can report bugs. And there's a wiki for some help. And we have a Google group for people to ask questions and send comments and so on.
And the LinkedIn community.
Sorry?
LinkedIn community.
LinkedIn. Yeah, we still have the link in forum for Sage. Yeah. So what is the hardware we recommend for you to start with? Basically, just start with one single PC. Don't go for the whole cluster mode right away. But something, a mid-range gaming PC, basically, a workstation you have somewhere in the lab. You can use Windows, Mac, or Linux. And we have done setup where it was a mixed architecture driving the wall. So we had half the wall in Windows and half the wall in Linux. And it doesn't matter. It's just running Chrome on top of everything. So you pick what you prefer. We're mostly using Mac and Windows as a testing platform. And basically you get a few 4K screens. That's very cheap these days. So one PC, if you got 4K screens, and you get yourself a very nice setup, and maybe a tablet and some laptops. What we showed shown at Supercomputing was a system which cost $6,500. And it was 3 4K screens from Amazon. So you just click and buy them. They're decreasing every week. And a gaming PC from Dell. Just a little feature that we like to point out. And if you get the latest NVIDIA card, you can get 4K 60p on your TV. Finally, you can get 4K 60p on your TV. And so for $6,500, or let's say less than 10,000, you can get 25 megapixel on your desk. And you can really do high resolution work and see all your data, basically. So we're going to try to
I think
demo?
we're out of time, right?
No, now you have your.
Oh, now we have our time to do our thing. Okay, cool.
Yeah.
So this is your part now. Lauren said we're supposed to do some kind of surprise. So the surprise is you're going to help us beta test this. So do you see that URL? So if you've got a laptop, and if you're daring, a tablet, point your browser, preferably Chrome,
Chrome,
to that site. And what you should see, if it's working.
So the URL is also on top, just above JSON, all the way on top.
Did you delete your thing? Okay.
Yeah, I was going to remove it.
So let me ask a question while we're doing this. Jason, could you actually virtualize all this and have your display node in one location and the Sage server in another location?
Yeah.
So let's say, for instance, in New Zealand, that would make it really easy for me to deploy these across the network without having to have anyone really know anything about anything except
potentially, absolutely,
push the button and open Chrome.
So if you have your browsers up and you've connected to that site, vroomsage.ucsd.edu, you should have.
Yeah, I did it.
Oh, you did that.
Yeah.
It was getting too slow.
Yeah, I mean we should clear it before we.
Oh, before they do this. That's
like
right.
Watching houseflies.
Yeah.
So I see. Yeah, this is good. So you all have her up there. So that's good. So we're going to play a little game now. The game is how many pointers can we get up here manipulating stuff and not crash Sage. So Luke is going to load up in a moment.
So can you just stop for a second? No, but just I can't load the stuff, otherwise it's...
So Luke is going to bring up the interface.
I don't know which one is mine.
Yours is at the top, Luke. Right dead ahead.
So when I say stop, it's stop. It's off the keyboard. Okay. Otherwise, I'm going to kick you out.
Luke, we haven't implemented that feature yet.
No, but I have to close those menus. So everybody's opening menus, and we have to close them.
Okay.
Oops.
All right. Please don't double click things, guys.
Yeah. So if you open a menu, close it.
I'll help them out.
You have a bug killer.
Okay, I'm going to restart it because it's annoying.
Okay, give Luke a chance to load up what he's supposed to load. Then you guys can jump in, okay? Give him a second here.
Okay, should be loading. Wow, a lot of people are connected. Indeed. I see the list. So we're going to load some session and let you do some work for us. So
you should have a non-democratic mode.
yes.
Clearly. It's called the CineGrid mode. Okay, Luke, are you good?
Yeah, it's loading.
Okay. So we're going to load up a bunch of images. And once they're done, Luke is going to set up something. Okay. But wait for it. Please don't jump in yet, because you'll mess it up if you don't. Oh, if you do. Luke is going to first take off all the borders so they look like jigsaw pieces.
Oops. Oh, somebody's moving it already. Okay.
Okay, wait for it.
Oh,
okay. So for those of you who moved too soon, you lost your pointers, so you got to connect back in again. Now for those of you who haven't, go ahead and connect into it. That's the solution. There are the pieces. We tried to get the new picture, but we didn't have time.
Is it get too slow?
Is it getting slow?
I don't know.
I don't know. Well, this is a good experiment to see how well Sage scales.
See my watch and I see my glass.
Do the corners like you'd rather really do in a jigsaw puzzle.
Oh.
There, done.
Oops.
Yeah, we should have given the easier one.
Yeah. So don't double click on the pieces, basically.
Yeah, if you double click on the pieces, it maximizes them, which is what's happening. So now you got to shrink them down to the normal size.
Are you wearing the same socks?
How about we do this? We have that side, the far side of the room, work on the far side of the puzzle, and we have this side of the room work on the left side of the puzzle. Let's see see if that works. Oh, you work. That's another way of doing it. You can work on yourself.
No, it's locked. No double clicking.
Somebody double clicked.
So while you're clicking around, does anyone have any general questions?
What's the URL again?
The URL
It's
is
too late.
vroomsage.ucsd.edu. Vroom, V-R-O-O-M.
If you get that wrong, it's not great.
If you get that wrong,
Put in .org.
So vroomsage.
UCSD.
yeah, ucsd.edu.
It's not.
It's not working.
Was it what road? The sales of
So when you play videos, basically we play videos also on an audio client, and that audio client is wired to the sound system of the room. So
Do you have a microphone app?
no.
Not currently.
No, we leverage video conferencing solution, Hangout, Skype, whatever.
Right.
My
So-
Chrome browser is saying that it's not a secure link. And you can,
UCSD.edu.
yeah.
Yeah. If it says it's not secure, you just hit the accept button.
You run Skype on here?
Not currently, because Skype is a standalone app.
Yeah, and it's not Sage. It's probably the wireless infrastructure.
Yeah, it's most likely it's sort of getting pounded on by wireless, but also I think it could potentially be Sage, because you've got a whole bunch of browsers, each getting updates for the location of each of these pieces on your browsers. So there's quite a bit of load going on. Yeah.
Yeah, but it's a web server.
Yeah. Well, something to study. Yep.
Yeah, that was going to be my
Jason,
question.
what about authentication of users?
Yeah, that's a good question. So we don't have authentication of users yet. So what we've started is an RFC that we're going to be publishing to send out to the community to see if the model that we have as an idea would work for everybody. Yeah. And that will be out very soon, actually.
And what about when you push a file up to the wall, where is it in the file system? Does it still go to the local server? Is it on the central server? In other words, is it on the server or the client?
It's on the server, right, Luke?
Right.
Yep.
Yeah, the client is just Chrome, so there is nothing to put there. So it goes to the web server.
Oh, somebody messed me up.
And are there any plans to
Come on,
to-
people.
sort of
Mhm.
direct that traffic to, someplace other than the server?
Yeah, so one of the little interface buttons, which you probably haven't seen yet, that we still haven't had time to work on, is the Dropbox button. To see if we can host a lot of these files directly on Dropbox, so it's automatically shared between sites. So we take away the load of us having to do. Yep.
What about Google Domain?
What about Google Domains? What was the question?
Google Drive file share.
We haven't got far enough to do that yet. Yep. But certainly, what we're hoping is that we have enough of a community who's interested in adding on those features that we will work with them to make it possible. Yeah. How are we doing back there?
I think we're out of time.
I think it looks really good.
All right, so we are out of time. Thank you all for
Yeah.
trying to solve our little puzzle here and helping us debug the system. Hope you had a good time.
Oops. Okay. Go. Stop.
Thank you, Jason and Luke. It's a very interesting presentation of the stage 2. So, any other questions? Because we are waiting for some preparation for the next stage presentation. So, do you have any comments or questions for the stage 2?
That's my guess.
Look, on the Jason. I have the one question about the first currently the bottleneck of the
Can I just ask?
your system.
Can everyone please disconnect, because we're going to restart the system. If you have the website open, the next presentation will not be interactive. So please close your browser, close your phone, do not connect.
Okay, not connect.
And I can't restart it until you do that. So please try to close it now.
They're using Sage.
Yeah. But what's the bottleneck at this moment for implementing the more highly interactive or more smooth interaction between the customers and the participants? Is a network or servers or the actual the browser implementation? So
For the bandwidth, the server I think is pretty good. It's probably the client side. And the fact that we use secure connection seems to slow down the bandwidth a little bit. So we have to look at that. And I know Google is trying to implement faster Cypher, faster implementation of SSL, for instance. But seems to be the browser is still kind of the bottleneck a little bit.
I see. So are you how can I say that the cascading that the servers or I mean that now is the server is here. So, but Jason will have the another server in Hawaii. So, can we cascading or some interaction between the two servers, or we can scale out the servers in the distributed way?
I think that's what Jason showed with the mirroring.
Mm-hmm.
So wherever is a server, everybody can connect and display the same content. And so eventually, I think the server, the web server part, is going to run in the cloud somewhere.
I see.
So everybody can access at the same speed and probably, hopefully, pretty fast, in fact. Right now, if you run the server here and the client in Hawaii, it's not really balanced. But,
I see.
In the client.
But also in your
Now I'm getting the node to use port 80.
Yes.
you can potentially run each one of those boxes
In the other